With rectangular coordinates, that's like a left and right, up and down. That's kind of like an etch-a-sketch sort of way of, locating a point in a plane. But with polar coordinates, you're working more with this circular way of locating points. You've got a radius and then you've got an angle, and that's the way that you locate your point. But the easiest way to do this is to go ahead and draw a triangle like I've drawn here. So to get to this point, I've gone right x, up y, and those are the coordinates, x comma y. But the other way to get there is just to draw a radius, okay, to that point. And you've got this angle here, the central angle, and that's another way of locating the point, r comma theta, right? But let's go ahead and show you where these formulas come from, and then we'll do some example problems. So the first one is like this. You can see from the Pythagorean theorem that x squared plus y squared is equal to r squared, right? So that's a key formula. And then if you take the square root of both sides, you can see that r is equal to the square root of x squared plus y squared. Okay, so if you're given an x and y value, you can solve for that radius, right? Okay, now let's go ahead and take a look at this angle here. So you can see that if you take the tangent of theta, that's equal to opposite over adjacent, that's y over x. And if you take the tangent inverse of both sides, you can see that theta is equal to the tangent inverse of y over x, right? So again, if you know the x and the y values, you can do the tangent inverse to find that angle. But now let's go ahead and take a look at this a step further. If we take the cosine of theta, right, cosine is adjacent over hypotenuse, so that's x over r, and by multiplying both sides by r, you can see that x is equal to r cosine theta. So you can see here, if we're given a radius and an angle, we can find the x coordinate, and then the same thing with the sine. If we say the sine of theta, that's going to equal what? Opposite over hypotenuse, which is y over r. By multiplying both sides by r, you can see that y is equal to r sine theta. So these are the two that we're going to be using in this lesson, switching from the radius and the angle to the x and the y. So let's go to this first example, 6 comma 30. Now I always like to draw a quick diagram just to kind of see what I'm working with. So basically what this means is you're going on a radius of 6 and then you're rotating 30 degrees. Okay, so it's like that. So there's 30 and there's a radius of 6. Okay, but what we can do now is we can take the radius, which is 6, times the cosine of 30. That's going to be our x coordinate. And we can take 6 times the sine of 30. And that's going to be our y coordinate. But remember from your unit circle, what's the cosine of 30 degrees? Well, it's square root 3 over 2 times the 6, right? So the 6 and the 2 reduce, so that's going to be 3 square root of 3. And what's the sine of 30? That's 1/2. So 6 times 1/2 is 3. So the location of this point using rectangular coordinates or xy coordinates, you're going to go right 3 root 3, up 3, and that's going to be the location of your point. So let's go to the next example, -10 comma pi over 4. So now we've got the angle in radians. Again, I like to draw a picture. -10, we're going left 10, and then we're rotating counterclockwise pi over 4. So that's going to be right here in the third quadrant. So this is a radius of 10, and we rotated 45 degrees like so. So again, same formula. We're going to take -10 times the cosine of pi over 4, and -10 times the sine of pi over 4. Remember, cosine of pi over 4 is root 2 over 2 times the -10. And then sine of pi over 4 is also root 2 over 2. You can cross reduce here, and this is going to give you -5 root 2 and also -5 root 2. So this is going to be the location of your point using x and y rectangular coordinates. You're going left 5 root 2, down 5 root 2. So I hope this helped you understand how to work with polar coordinates and specifically converting from polar to rectangular. In the next lesson, in the next video, I'm going to be doing the reverse, how to go from rectangular back to polar. So subscribe to the channel, check out more math tutoring videos on my YouTube channel, Mario's Math Tutoring, and I look forward to helping you in the future videos. I'll talk to you soon.